Manufacturers spend a lot of time and effort in specifying, designing, sizing the cooling system to keep the engine temperature within its limits in the most extreme conditions, climbing a hill, pulling a trailer in a desert with the radio jammed on a Justin Bieber marathon. So, while the coolant system needs to have this capacity to cool in extreme heat, most of the time we're just plodding along at a more sedate pace. So there needs to be some way of controlling the amount of cooling being done. And we don't want to overcool the engine, or because we'll lose efficiency and performance. So this control is mainly achieved through the thermostat, but it's also partly done by controlling the airflow through the radiator with the radiator fan. We'll look at that soon. The thermostat controls the circulation of the coolant. Basically, it's a temperature controlled valve that blocks off the flow out to the radiator. When the engine's cold, the coolant just circulates around inside the block driven by the pump. But once a temperature of say 82 degrees Celsius is reached, the thermostat starts to open and allows flow out to the radiator. On this engine, our thermostat is at the front and it sits inside this thermostat housing. You'll normally find a thermostat high up on the engine because that's the hottest part of the cooling system and it's where the hot water comes out. The general flow of coolant around this system being cold water out from the bottom of the radiator into the bottom of the block, heated up, rises out of the top of the block into the radiator and back around. Hot water rises and cold water sinks, so this flow makes sense. And thermostats probably need to be replaced within the lifespan of the engine, so they really need to be easily accessible. So this is our thermostat, and they are really a brilliant piece of engineering. Reliable, simple, there's no electronics or sensors in here, it's totally self-contained, pretty cheap to produce. All modern cars use a wax element type thermostat like this one, and they're pretty much all the same. The basis of wax thermostats is that when wax melts and it changes from a solid into a liquid, it expands in volume. And that's normal for most substances except for water, which goes the other way. But wax melts around the operating temperature of the engine and it expands quite considerably. So wax is a perfect thing to use inside here. In the centre of this thermostat is a metal chamber of solid wax, which is completely sealed except for an opening at the bottom where a pin rests inside the wax. When the wax melts, it takes up more space and pushes down on the pin, which acts a little bit like a piston, lifting the capsule. A disc valve is attached to the capsule, and when the disc moves up, the thermostat is opened. A rubber seal around the disc ensures a watertight seal when the valve is closed, and a spring pushes the valve back against the wax so that when it cools down and solidifies, it takes up less space and there's room for the pin to return into the wax. If we take a look at the frame on a thermostat, we'll see that there's a small air bleed hole here, and that allows air to pass through. This is needed when you're refilling the coolant, because otherwise pockets of air can get trapped behind a thermostat and they can't get through into the piping system out to the radiator. Now, when you replace a thermostat, you need to make sure that this hole is at the top. Otherwise, it's underwater and the air can't pass through it. There's also a little pin here, a little wobbler pin, which wobbles around to stop this hole from being blocked. It's called a jiggler pin. This thermostat is a single valve thermostat. You'll also find a double valve thermostat, which has another valve. And there's two different designs. There's ones where you get a second sub valve, which is kind of stacked on top of this. So we've got a valve on top of a valve, or there's this design where you have two valves side by side. So there's a main valve and a sub valve, and they may operate at slightly different temperatures. The temperature that the thermostat operates at is stamped on the frame, on the actual frame of the housing. So this one, 85, 88, so that's the temperature it starts to open and the temperature it should be fully open at. The temperature, the operating temperature of a thermostat is set by the blend of wax that's inside the capsule here, and different temperatures are used for different engine setups. Now, thermostats do fail. They should be good for 100,000 miles or so, but that's less than the lifetime of a typical engine, hopefully. So there are two failure modes that you need to think about with a thermostat. One is the thermostat might fail closed. If it fails closed, then the engine's going to run hot because the coolant isn't getting out to the radiator. So the engine will likely overheat and you'll notice it pretty quickly. Now, if an engine has overheated for whatever reason, it's worth checking the thermostat to make sure that it's still working, because they do get damaged by extreme heat. Also, a thermostat that's failed open, which is the alternative failure mode, will make the engine slow to heat up because the coolant's flowing around the radiator all the time. Now, this is probably a little bit more difficult to notice, but it's going to show up as a range of symptoms. Could be poor heating inside the car, the fan blowing cold in the cabin, poor running, excessive fuel consumption, that sort of thing. So it's easy to check a thermostat. Firstly, you'll need to drain the coolant, partially drain the coolant to bring the level of coolant down to below the level of the thermostat in the engine. Then pull the thermostat off the engine and check the condition of the valve. Now, if it's open when you take it off, then it's failed. You can check where a thermostat works by putting it in hot water and seeing what temperature it opens at. And if you put a thermostat into boiling water, any thermostat should be open at that point. This thermostat is failed. Another thermostat that came out of this engine is also failed, so it's fairly common. And on this one, you'll see that the rubber inside here is all cracked, so we'd have a terrible seal. Now, when you're replacing a thermostat onto an engine, you need to make sure that the wax element, the spring side of the thermostat, goes on the hot water side of the thermostat housing. If you were to put this in the other way round, then the wax element, the actual temperature sensing part of this, will be sitting in cold water and it won't actuate the valve. The other thing to watch for, of course, is to make sure that your wobbler pin is at the top in the housing. That is thermostats. The end. Everyone lived happily ever after.